Welcome to today's lesson. I'm Siamsaka Kirendens. Today, I'm going to take you through the lesson on the organic chemistry, and in particular, we'll focus on the polymerization. And so we'll go through the lesson right away. Actually, there are two, in general terms, we can say there are two types of polymerization. That is the addition polymerization and condensation polymerization. Remember, earlier we looked at the addition polymerization, where the monomer units actually are joined or combined together to form a polymer. And in this process, actually, there is the breaking of the bonds for the monomers, and it produces the same number of atoms for the polymer. That's in brief terms, that's what we can say about addition polymerization. And so today we'll basically look at the condensation polymerization, where actually the monomers as well join together to form a polymer. But in the process of this combination of the monomers, we actually move the small units or small molecules. For example, we can be removing water, and that's why it's known as condensation polymerization process. And so the condensation polymers, as I stated earlier, are formed through condensation polymerization reaction, where molecules are actually joined together while losing small molecules as byproducts. And in addition, polymerization, monomers react to form a polymer without a formation of other byproducts, because you just join the same monomers to form the chain, a large chain, which is a polymer. While in condensation polymerization, actually, you remove the small molecules, and so then you form actually a polymer as well as that small molecule that was being removed. And so today we'll look at synthetic polymers, how we can form non-natural polymers. And so we'll concentrate on the two, nylon and terylene. Nylon is a polyamide because it has an amide linkage in it, as you'll see later on, while terylene is a polyester because it has an ester linkage, as you see in the next lesson. And so for this lesson, we'll concentrate on the actually polyamide, which is nylon, how it's formed, its properties, and the structure. And so nylon is made when monomers are combined together to form a long chain, and this long chain is actually known as a polymer, and this process is known as polymerization, and is formed by the process known as condensation polymerization, because actually you remove small molecules, which is water. And so it is typified by the amide group, because you have to actually find the amide group. Okay, and so there can be more than one monomer, like in addition polymerization. And so here are the two types of monomers that we'll look at, which are joined together to form the polymer. We have the hexamethylene diamine, and so you'll notice that here there is a backbone which is given by this rectangle and shaded. And so at the end here, we have nitrogen linked to two hydrogen atoms. And the other end, again, you have nitrogen actually linked to two hydrogen atoms. That's why it's known as diamine. So basically, this linkage, this nitrogen actually with a bond to hydrogen and nitrogen with a bond to another hydrogen is an amine. And so it is diamine because this side you have an amine and this side you have an amine. So this is a monomer which we will use actually to join together with another monomer to form a polymer which will actually eventually give us nylon. And so the other monomer is adipic acid, and so also it's hidden by a backbone. The intermediate actually compound, it's actually represented by a rectangle here. Here, actually, these rectangles, this one and this one, it shows that there are other molecules here which are hidden, and so we represent them with this rectangle. It can be of different shape. But so at the end here, you have actually carbon linked to oxygen through double bonds and the hydroxyl group on the other side. Similarly, even the other side. And so this is the second monomer that will be joined to the amide, which we have talked about earlier on. And so this is the process of how nylon actually is formed and its structure. So we have this amide unit or monomer, and we have this acid monomer, and again you have, so they will be alternating like that. You have the amine, the acid, the amide, and the acid in that order, and then you remove, for you to form nylon, you have to remove actually hydroxy group from the acid and the hydrogen from the amine. Similarly here, you remove hydroxy group from the acid, and here remove hydrogen from the amine. Similarly, go on and go on and on. And so what you form later, it means that this nitrogen now will be joined to this. Remember the backbones are the same here. This backbone for the amine is the same, and the backbone for the acid is the same as well. And so you join now the nitrogen to the carbon, meaning nitrogen will be bonded to carbon. Again here, carbon will be bonded to actually to nitrogen. And then this hydrogen, the one which is remaining, which we brought here, it doesn't matter. It can be up there or up there, it doesn't matter. And so this is the structure. So this structure repeats itself. As long as you have these alternating, you have the amine, and then in the acid, the amine and the acid. So when you see such a structure, actually, this is the structure of nylon. And so it has least linkage. This linkage is what is known as the amide linkage. So this linkage here is known as the amide linkage. It's also found in proteins, as we will see later in later lessons. In a peptide, actually, you find this same linkage. And so this is how actually nylon is formed. And now we'll look at the properties of nylon. Nylon actually is widely used in our day-to-day life, and it's very versatile because it can be manipulated and be used according to our needs. So because of its toughness, it has found itself being used in many areas, as well as it's very resistant to abrasion, cannot easily scrub it. So at times you can make even carpets which are very resistant to abrasion. It's also easy to wash. It can be dirty and you can easily wipe it with water and even an organic solvent without it actually changing its type. And so it's also easy to dye. You can easily make it in the color that you'd want. So it has a wide range of dyes. Also, it is very high resistance to even light. It cannot easily fade, and it's very lustrous. And so most organic solvents have no effect at all to nylon. Even if you actually dropped it there, it cannot actually affect it. And also it does not discoloration. Discoloration is not the ritual discoloration due to light is actually observed in a nylon. Also, it is elastic, it dries very quickly, resistance to corrosion, and it has high insulation, especially that's why it is particularly used in cables actually in electricity. And so we have seen a variety. This is not limited to what actually the properties of nylon are. We have several of them, and so I've just listed a few of them here to show that actually nylon is widely used as a synthetic fiber. And so we have different types of nylon. It depends on the raw materials that you are using, particularly the monomers. So we have nylon 6, nylon 510, nylon 1,6, nylon 66. All these are actually used according to the areas where you would want to use them. And so you can form the particular monomers according to meet the demands of the cells that you want to provide. And so these are the types of nylon, as well as the uses of nylon, as I indicated, because of its properties. You can use it for clothing. You can use it in industries to make ropes, tents, seat belts, and many other utilities. And also you can use it to make fish nets because there's no corrosion even if you put it in water. Also in machine plastic parts, it can also be used. And so I thought today we'll look at the formation of nylon through the process of condensation polymerization, look at its structure as well as its properties and uses. And many these questions on actually its formation are always asked, as well as the structure. And so we should have keen interest to really know the linkage as well as the structure of nylon, so that even when it comes in an exam, we are able to appropriately identify it. And so I thought today this is what we can look at. And so subscribe to my YouTube so that you can receive more of these lessons. Thank you.